As an Ansys partner since 1984, we are highly committed to helping you design, simulate, and succeed.
In this video, I'll be demonstrating the associative link between Creo and Ansys Mechanical. This functionality greatly improves the analyst's ability to evaluate multiple designs efficiently. And in the case of this fluid pump, I'm specifically going to be evaluating the performance of different discharge flange thicknesses. So here's the geometry in Creo, and I'm going to go ahead and take that into Mechanical and set up the analysis and solve it. So you can see that as an analyst, I've imported the geometry, I've set up my connections with both linear and nonlinear contacts, I've defined different mesh characterization, I have applied loads and boundary conditions, including this bolt pretension, which is going to be the primary loading for this analysis. And this results in a stress distribution on the flange that you can see here, and anywhere in red that exceeds my 32 KSI design criteria, so I do need to make a design change for this flange. So in order to do that, I'm going to go back to my Creo interface, and I already have a parameter set up, so I'm simply going to change the thickness of that flange from 1 to 2 inches and regenerate the design. You can see that that increased the thickness of the flange. And going back to Mechanical, all that's required for the analyst is to right-click on geometry and update that geometry from the source file. Once that happens, you'll see that this flange thickness increases from 1 inch to 2 inches, and I can go ahead and resolve the model. And the nice thing about the associative interface with Creo is that I don't need to redefine any of these contact definitions. I don't need to redefine any of my meshing definitions. I don't even need to redefine any of the loads or boundary conditions. So all of these things that I scoped previously have been maintained due to that associative interface. And so just by hitting solve within a couple of seconds, I can get the updated result. And so here in a second, we'll see that evaluate, and you can see that the updated stresses on the 2-inch flange are significantly lower. We could continue this process for different flange thicknesses and even automate that process using something like the Workbench design point table. So I hope that you found this video helpful. You can check out the full-length webinar covering this process in greater detail, as well as the Creo Associative workflow with Ansys Fluent in the link below. You can also find numerous other technical resources on our website, as well as a sign up for upcoming mechanical trainings. Thanks for watching.
Contact us today to discuss your unique physics challenges and find the right Ansys tools for you.